Let us look at the question about prisoners in a brand new light. Look at this example here. A, B, C, D, E, F, G, H are the 8 prisoners. A hates B. You cannot put A and B in the same cell. They'll kill each other. A hates F and so on. One less commonsensical way is to simply put each one of them in a different prison. But you see, A and E can actually be in the same prison. You can reduce a prison cell, right? So, pause the video and try to figure out what is the minimum number of prison cells that you can think of, so that you can put these prisoners in the prison cell so that no two enemies belong to the same prison cell. Is this even possible? Yes, of course, I showed you. If you had 8 prison cells, it's possible for you to assign 1 per prison cell. Can you reduce it? How less can you manage with? Think. Okay, I think you all gave it a thought. Here goes the answer. Look at this. 1, 2, 3 is the naming convention I have used to denote the prison cells. So this fellow goes to prison 1, 1, 1, 1, and these 3 people go to prison 2, and only 1 person goes to prison 3. Basically, A, C, G goes to cell 1, B, E, H goes to cell 2, and F goes to cell 3. Correct? This is one way of doing it. The other way of doing it is simply this: A, D, G, B, E, C, F, G. There may be many such ways, right? Okay. Think about what we just did. Now, let us cut the example from where we started and look at the mathematical definition for which the prisoner's question was a motivation. The definition goes by the name proper coloring. It means, given a graph G, can you color the nodes in such a way that no two adjacent nodes have the same color? Don't you think this is precisely what we have been discussing with the prisoner's question? It is exactly the same, as you can see. Correct? So I repeat, given these prisoners and given the enemy network, you must ensure that no two enemies belong to the same prison cell. Can you minimize the number of cells and try to figure out who should be assigned to what prison number so that no two enemies come in the same prison? This question is same as, can you assign with minimum number of colors? Assign colors to all the vertices such that no two vertices that are adjacent have the same color. This is called a proper coloring of a graph. A proper coloring of a graph is simply assignment of colors to vertices such that no two adjacent vertices get the same color. But the question here is, obviously, if you color every single node with different colors, it's a proper coloring. But what I want is the minimum number of colors. That minimum number of colors is called the chromatic number. Right? We will see this more right now. We have already seen it, but I'm just telling you the connection between simply proper coloring and the minimum number of colors required, and that is called chromatic number. You saw the example of prisoners. You just saw the raw definition equivalent to that of prisoners, and that is proper coloring.